Good day, Dr. Emmanuel P. Aboso, our Advanced Statistics Professor. I am Clarife A. Montesclaros, first year MAE student, and today I'm going to present my critical analysis of a published paper indicating the F-test for two-way ANOVA with interaction. But before I present my critical analysis based on the published research I had chosen, let me give first an introduction and an overview of the statistical tool that I was assigned to discuss. What is two-way ANOVA? Two-way ANOVA is an analysis method for a quantitative outcome and two categorical explanatory variables. If an experiment has a quantitative outcome and two categorical explanatory variables that are defined in such a way that each experimental unit or the subject can be exposed to any combination of one level of one explanatory variable and one level of another explanatory variable, then the most common analysis method is the two-way ANOVA. Because there are two different explanatory variables, the effects on the outcome of a change in one variable may either not depend on the level of the other variable or the additive model, or it may depend on the level of the other variable or the interaction model. Note that the concept of interaction versus an additive model is the same for ANOVA or a two-way ANOVA. In the additive model, the effects of a change in one explanatory variable on the outcome does not depend on the value or level of the other explanatory variable, and the effect of a change in an explanatory variable can be described while not stating the fixed level of the other explanatory variable. And for the models underlying both analysis, if an interaction is present, the effects on the outcome of the change in one explanatory variable depends on the specific value or level of the other explanatory variable. Now, this time I am going to present my critical analysis of a research paper entitled Biochemical and Molecular Action of Nutrients, Actions and Interactions of Thyroid Hormone and Zinc Status in Growing Rats 1 and 2 by Hedley C. Frake, Kristen E. Govoni, Krishna Buddha, Chun-Li Wang, and Stephen A. Zinn from the Departments of Nutritional Sciences and Animal Science University of Connecticut, Stores, published 2001. For the abstract, both thyroid hormone or thiodo-L-thyronine and zinc play important roles in growth and development. The T3 receptor is thought to require zinc to adopt its biologically active conformation. Some of the effects of zinc deficiency, therefore, may be due to loss of zinc from T3 receptor and impairment of T3 action. This possibility was investigated in growing rats by examining the effects of hypothyroidism and hyperthyroidism in zinc-deficient, pair-fed, and control rats. Measurement of serum zinc and T3 confirmed the efficacy of the treatments. Zinc deficiency and hypothyroidism resulted in lower food intake and growth failure, but no interaction was observed between the two treatments. For the statistical analysis, the influences of diet and thyroid status were analyzed in a randomized complete design using the SAS Institute General Linear Models. Data are expressed as mean 6 SEM. If the main effects were significant, P0.05, then the means for the individual treatment groups were compared using the PDIFF tables within SAS. Initially, there were 5 rats within each treatment group. However, one rat in each thyroid group fed the zinc-deficient diet did not reduce food intake and therefore gained weight at a much faster rate than the treatment mates. These rats and their pair-fed controls were excluded from the subsequent analysis. In addition, 2 rats died and the serum sample was lost from one other, resulting in their exclusion. Thus, groups contained 3 to 5 rats. The overall hypothesis underlying these experiments was the lack of zinc might impair thyroid hormone signaling by reducing the ability of the thyroid hormone receptor to bind to DNA and thereby influence target gene transcription. It seemed appropriate, therefore, to look directly at a target gene and determine the ability of the T3 to influence its expression in the different dietary groups. Lukaski et al. Showed that zinc-deficient rats had reduced ability to withstand cold stress. Wada and King reported that marginal zinc deficiency in humans was associated with a reduction in basal metabolic rate. Both findings are consistent, with zinc deficiency resulting in impaired thyroid function. And for my insights, the experiments reported here did not uncover the effects such as this with respect to growth, the somatotrophic axis or mRNA-S14. Although some interactions between the two main effects were found, for the most part, these important regulators of growth and development appeared to be acting independently. However, it remains possible that interactions will be found as the other indices of thyroid hormone actions are examined. Now, it is critical for a researcher to understand the ideas of basic statistical procedures utilized in research studies. This will aid in the conduct of a well-designed study that yields valid and reliable results. Incorrect statistical procedures can lead to erroneous results, resulting in inaccuracies and diminishing the article's significance. Bad statistics can lead to poor research, which can lead to unethical behavior. As a result, a solid understanding of statistics and the proper application of statistical tests are critical. A basic understanding of statistical methods will go a long way toward enhancing research designs and providing high-quality researches that may be used to develop evidence-based guidelines. And that would be all for my presentation for today. Thank you so much, Dr. Emmanuel P. Abozo.